Howdy folks, welcome to Module 6 of the Security Plus course. As you can see, this module is titled Secure Cloud Network Architecture. Now today's module, guys, consists of only two main sections, so everything we're going to be discussing is going to be divided between these two main sections. Like usual, if you're looking for something specific, you can find that in the video description down below. Now, as for today's two main sections, the first one is cloud infrastructure. So we're going to talk a bit about cloud infrastructure there. You know, what is cloud, the different kinds of cloud you get, security related to that, of course. The second main section we'll be talking about today is embedded systems and zero trust architecture. Right, folks, before we jump into the first main section, you know what to do by now. If you haven't done it already, give the video a like. And of course, if you'd like to know when Module 6 goes live, maybe consider subscribing as well. Alright, let's go jump into the first main section. Alright, here we are, guys. The first main section is cloud infrastructure. And then the first topic we're going to be talking about in this section is cloud deployment models. So for those of you that don't know what the cloud is yet, I assume most of you guys know what the cloud is if you're doing this course. But if you don't know what the cloud is yet, it is the concept of putting something somewhere else on somebody else's property. So if you've got data or programs or virtual machines or whatever on your own server or laptop or desktop, that's all it is. It's just data, programs, virtual machines, and blah, blah, blah. If this is on a server, but the server belongs to you or your company and you access it via your own network, it's still just, well, applications and data and virtual machines. Even though you might access it remotely, it's still your server or your company's server. So it's not really cloud just yet. But if you put those items I've just listed on a server that does not belong to you and it does not belong to your company, that is usually a form of cloud. So if that server belongs to some other entity, possibly, Amazon, so that will be AWS or Microsoft, so if this server belongs to one of these big, well-known entities and they render it back to you as a service of sorts, usually for a monthly fee, sometimes a yearly fee, but it's usually a monthly fee. That is cloud. Now, something interesting about this, guys, is it does not matter where that server is. This server could literally be in a building next door. It could be across the street or even in the same town as you. The fact that it's on somebody else's server and the fact that it's being rendered back to you as a service over the internet for a monthly fee, that makes it cloud. Or at least it's kind of a form of cloud. Now, when it comes to cloud, guys, you get different deployment models, which is the actual topic here. The three different kinds you get is private cloud. That's the first one. Now, private cloud is honestly the most expensive kind of cloud you can get, guys. This is when an organization, such as yourself, has its own data center. Not just a server room, a data center. Data centers, guys, I'm not sure when last you've checked, they don't come cheap. They are very expensive. So either you have your own data center or you've got access to a data center near you. So maybe you are renting space in a data center and you and your staff members have the ability to go to this data center and you can go and slide in one of your servers into one of their server racks and you've got access to it. So downside, the very obvious downside here is the cost factor. Very, very expensive. You might have to go and sell a sibling to be able to afford this. A benefit to this is you've got direct access. You've got a lot of control here. Another downside, though, would be you are in charge of maintaining it. You are in charge of backing it up. So if it needs to be upgraded, whether it be hardware or software, guess whose problem that's going to be? It's going to be your problem. When it needs to be backed up or restored because something failed, yeah, that's going to be your problem. So it does have a couple of major benefits, but it does have a couple of major drawbacks as well. So a lot of companies are not very keen on a private one, and you do get companies that like this, but most companies like what we call a public or a hybrid deployment model. Now that brings me to the next topic here. public deployment model. Public deployment model is a very popular option, guys. So this is a public cloud type. It means everything of yours, or if you've got a client, everything of your client is 100% online, 100% in the cloud. So whether this be Active Directory, whether this be virtual machines, whether this be a website that's being hosted, whether this be a SQL database, it doesn't matter. Whatever it is, it's 100% being hosted online by a cloud provider such as Amazon or such as Microsoft. Obviously, it's not limited to those two. Those are just two very well-known ones, so that's why I'm mentioning those two. I'm not promoting or demoting any brands here. So if I go and make a virtual machine now, and I make it in the cloud on a platform like Azure, Microsoft's Azure platform, or Amazon's AWS platform, if I go and make a virtual machine there, or I go and upload it to that platform, that would be an example of public cloud. You get actually subcategories of public cloud too, mind you, which we'll get to in just a moment. So it's an example of public cloud. If I go and upload my SQL databases completely to a platform like the Azure website, yes, that's also an example of public cloud. So whenever you or one of your clients goes and uploads their stuff completely online to one of those big platforms I've just mentioned, like Microsoft Azure or Amazon's AWS platform, that will be an example of public cloud. You don't have servers on premise anymore. All your servers, if you have any, would be 100% online. Now there's benefits to this, there's drawbacks to this. With public cloud, no matter what type of public cloud you choose, because you do get different types of public cloud, with all forms of public cloud, you are going to be relinquishing some level of control. The cloud provider, it is their responsibility to maintain your stuff, to back up your stuff, and to secure your stuff. Now, you're not going to have no control. At the end of the day, you're still going to have to go and configure it and tweak it and tell them what security you want, how you want it configured. At the end of the day, they're not psychic. They can't smell this stuff. You need to tell them how you want it and what exactly you want. So they will give you the options, but it's still going to be your responsibility to go and tell them how you want this tweaked and how you want this configured and all that. But you are unfortunately going to be losing certain level of control when it comes to public cloud. As for hybrid cloud, guys, hybrid, whenever you see the word hybrid in IT, it normally is a combination of something. In this situation, it's obviously going to be a combination of private deployment and public deployment. So if this is your company with a hybrid deployment, that would mean you still have some stuff on premises, and at the same time, whatever that stuff is, you've got that same stuff online in the cloud. A couple of random examples of this will probably be Active Directory. So maybe you, your company, or your client's company, still have an old school Active Directory server on premises, and at the same time, this company has an Active Directory online now on a platform, let's say, like Microsoft Azure. So we used to call this Azure Active Directory. Nowadays, it's referred to as Microsoft's Entra ID. It's the same thing though, it's just a fancy new label that they've slapped onto it. So you've got your old school Active Directory on premises. So in other words, you've got the ADDS role installed on a server on premises. This could be a physical server on premises. It could be a virtual server on premises. The point is, it's still a server on premises. So you've got the ADDS role installed on premises on a server on premises, which could be physical or virtual. And at the same time, you've got a cloud Active Directory on something like Microsoft Azure's portal, which is probably going to be Entra ID. And you've synchronized these two with one another. Alternatively, this could also be something like SharePoint. It could be something like Exchange. You know, just to give you guys a couple ideas. So at the end of the day, hybrid is when you've got something on premises and that same something is online in the cloud now, and you've synchronized these two somethings with one another, whatever it might be. Could be Active Directory, could be SharePoint, could be Exchange. It could be a lot of things. The point here is it's on both sides of the coin here. Now folks, still on the topic of cloud deployment models, a couple of security considerations. So when you move stuff to the cloud, a very obvious concern is obviously going to be security, that, and of course functionality. But we're not talking about functionality right now, we're talking about security. So about 10 years ago, you know, when the cloud was still a relatively new term for a lot of companies, I had such a mission to try and persuade companies to go to the cloud. Some of them had no idea what the cloud was. Some of them did know what the cloud was, but they had concerns about functionality and especially concerns about security. They were not very sure if the security in the cloud was as good as what they had on premises. So that's a very good concern to have. I mean, obviously you need to have concerns like that about security and functionality and stuff. We're not just going to go and willy-nilly move our stuff to the cloud. No, we need to make sure about our facts here. We need to make sure that the security in the cloud is the same, if not better. We need to make sure the functionality in the cloud is the same, if not better. Now, back then, 10 years ago, the cloud security was very good. Obviously not nearly as good as it is right now, but I wouldn't say it was bad. It was very good still 10 years ago. It was still very, very good. Now, unfortunately, because people didn't exactly know what the cloud was and how the cloud worked and all that, they had some major concerns about the security of the cloud, which is why it was such a mission of note to try and persuade customers and potential clients to move their stuff over to the cloud. So if we did manage to persuade them to go to the cloud, they would normally tippy-toe into the water of something simple, like their exchange. So they would go and move their exchange to the cloud. They would normally go and move over to Office 365. I think most of you guys would probably know what Office 365 is. So they would move their email over to Office 365, and that's how they would start the process. They would do that for about 3 months, 6 months, or 12 months. And if they like what they see, they like the functionality, they like the security, they'll then ever so slightly, slowly start moving something else to the cloud. Maybe they'll move their SharePoint to the cloud or something else to the cloud. So it was a gradual process. Fortunately now, we find ourselves at a point in time where most companies have moved most of their stuff over to the cloud. Unfortunately, there's still a few things where companies are still kind of stuck in a hybrid situation. That's a topic for another day. One such example will be Active Directory. You'll find a lot of companies are still stuck in a hybrid situation of Active Directory. It's not really because of security considerations. That's more of a functionality, perspective. Unfortunately, the on-premises Active Directory does provide a couple of benefits that the cloud one does not. And the cloud one provides a couple of benefits that the on-prem one does not. So companies kind of find themselves stuck in the middle here with running both of them at the same time because they want the benefits of both sides. But that's a topic for a different day. Other cloud deployment model things you guys need to consider is single tenant architecture and multi-tenant architecture. Now, single tenant architecture is if you are the only person on a server, for example. Now, if you're going to go and do that, guys, you need to expect to pay more because that's what's going to happen here. So if you are concerned about security, if you're a very paranoid person, yes, you can get yourself a dedicated server usually with a cloud provider like Amazon or like Microsoft. It's very much possible to go and do so, but if you are going to go and do so, you need to expect that you are going to be paying more for it. Alternatively, which is the more popular option, this is what most companies do by default, multi-tenant. So that means you are sharing a server with other random people and other random companies out there in the world. Now, these cloud providers like Microsoft and Amazon, obviously it's not limited to these two big ones. I'm just mentioning them because that's the two main ones. So these two main big cloud providers, they've got many servers, guys. So many. I have no idea. I just know it's many servers. Now, when you go and store something online, or you go and create something online, like a website or a virtual machine, whatever it might be, that item you have stored or created or that you're running in the cloud now, it's running on one of these two big cloud provider servers, but that server on which it's running, it is being shared by other entities out there in the world. So if you have, let's say, 10 virtual machines that's running on a server of Microsoft, that same server is probably running a whole bunch of other virtual machines for other random people and companies in the world. So that is what multi-tenant is. You are sharing that server. This is actually a concept that we call resource pooling. It's not something you guys need to worry about. It's not a topic that's covered in this course, but it's called resource pooling. It means you are sharing a server with other entities out there in the world. Now, with that in mind, there's obviously a couple of security concerns about that. Some companies might be concerned about something called data leakage. What if my data gets leaked and these other entities on the same server happens to somehow miraculously get a hold of my data? Now, that's not something I've ever seen happen yet being the key word here, But if you are concerned about things like that, you can of course go and pay the cloud provider a little bit extra, and you can go get yourself a single tenant, a dedicated server. I mean, there's nothing you can't achieve in this world by not throwing a little bit of extra money at it. I mean, you can, as long as you're willing to throw a little bit of extra money, you can achieve pretty much anything in this world at this point in time. Now, but you've got to keep in mind, guys, these cloud providers, they've got massive IT budgets. They've got massive security. They've got top-notch security technicians there and all that. So they really know what they're doing. So the chances of there being something like a data leakage is very, very unlikely. This hasn't happened yet that I'm aware of. It might just be that I'm not aware of an incident. But if you are concerned about that, get yourself a single tenant. Then, of course, we've got hybrid architecture, which is pretty much the same concept which we explained earlier. Your company has got, some stuff on premises, and at the same time, you've got some stuff online. Now, why is it mentioned again? Well, we're talking about it from a security perspective now. So if you are very, very paranoid about your security, instead of getting yourself a single tenant, what you can go and do is you can go and keep a couple of servers on premises, and whatever you deem as too important or too sensitive to put in the cloud, you can keep that on servers on premises. And the stuff that's maybe a little bit less sensitive, a little bit, stuff that you're less concerned about security-wise, that you can go and put online. And then the last thing I want to mention here, folks, before we move on to the next topic, serverless architecture. So that pretty much just comes down to public cloud again, where everything is online. You've got no servers on premises, which means you've got no responsibilities in the sense of maintaining and backing it up and securing it. It's everything is 100% online, so it's 100% the cloud provider's responsibility. They need to make sure it's maintained hardware-wise, software-wise. They need to make sure it's secured. They need to make sure it's backed up. So that would be a serverless architecture deployment model. So it's basically just public cloud in a nutshell. All right, folks, let's move you on to cloud service models. All right, so with regards to cloud service models, think of these as subcategories to what we spoke about earlier. More specifically, subcategories to the public cloud we spoke of earlier. Now, if you think about public cloud, that is when you put everything somewhere else on somebody else's property, like I said earlier. Now, within public cloud, you get many categories. But the three main ones, and the three most common ones, we refer to these as models, by the way, they are infrastructure as a service, which we just call IaaS for short. It is platform as a service, which we call PaaS for short. And then, of course, we've got software as a service, which we call SaaS. And once again, that is simply the three most common categories. It's the three most widely used categories, but it's in no way or no means the only category. So before one of you guys go down in the comment section and say, hey, but I know you get this one, and hey, I know you get that one. Yes, we're well aware you do get other ones, but these three are the three that's specifically mentioned today. In today's module, it's the only ones that's discussed in this part of the course. You guys do need to know what these three are, not just the names, but you need to know what they actually entail. So I've mentioned earlier, with public cloud, you're always going to be relinquishing some level of control. The question here is, how much control are you going to be relinquishing? Now, depending on which one of these three you use, that will determine how much control you still have and how much control you don't have. Now, if you look at the first one there, guys, infrastructure as a service, with that one, you've got the most amount of control. Now, to give you guys an example of what this might be, a very good example will probably be a virtual machine. Specifically, a virtual machine in the cloud that's being hosted online on some platform like Microsoft Azure or Amazon's AWS platform, that kind of stuff. So if you've got yourself a virtual machine which is being hosted on your laptop or your desktop or your company's server, that's all it is. It's just a virtual machine. It's just infrastructure. It's not infrastructure as a service. It's just infrastructure. But if you were to go and take that very same virtual machine and you upload its hard drive into the cloud, it's normally a .vhd file, by the way, if you go and upload the virtual machine's hard drive into the cloud onto something like Microsoft Azure, or you go and create this virtual machine from scratch on a platform like Microsoft Azure, that, folks, would be infrastructure as a service. Why, you ask? Because now this virtual machine is occupying space on their hard drive, on their storage, not your storage. It's using their RAM, not your RAM. It's using their CPU cycles and their network cards. So it's using their resources, is what we're saying. And they're, of course, rendering this virtual machine back to you as a service. Hence the name, infrastructure as a service. And you, of course, will be paying for this service. Normally it's a monthly fee, but if you want, you can go and, of course, make this a yearly fee. Now, if infrastructure is a service, guys, you can't see or touch the actual data center or, the server room. So you can't see it. You can't see or touch the actual network cabling and all that. But you can still choose everything. So when it comes to the actual virtual machine's specs, you can go and choose the exact amount of storage you want, how many hard drives you want, how big they should be, how fast they should be, I kid you not. You can go and choose how much RAM you want. You can go and choose how many virtual machine CPUs you want. You can go and choose how many virtual networks you've got, which is basically the equivalent of a virtual switch on Hyper-V, or should I say a network cable in the cloud if we have to go and really dumb this down. So you can go and choose how many network cards this machine has to have, and how many networks it needs to be. So clearly you guys can see here, you still have a lot of control here. I might not be able to see and touch the actual servers on which my stuff is being hosted. I might not be able to see and touch the actual cables, but I can still choose the exact specs, and I can still go and choose the networking that I want. So you still have a lot of control here, guys. And once you install the operating system on that virtual machine, and you can choose any operating system you want, by the way, once you install the operating system on a virtual machine, you've got full outright control. So you still have an amazingly a lot of control. Now, if we go down this little ladder of ours, PAAS and SAAS, you're going to gradually have less and less control. Looking at platform as a service, folks, with that one, you've got less control now. Less than infrastructure as a service, which we just spoke of. So I can give you guys many examples, but this is a very tricky one to explain. So a couple of common examples that comes to mind will probably be something like Active Directory in the cloud, Azure Active Directory, or as they now call it, Entra ID. If you look at your normal Active Directory you have on premises, what would I need to do to get that? You would need to go and get yourself or build yourself a physical or a virtual server. Once you've done that, you would need to go and install the server operating system. Once you've done that, you would need to go and add a role, if you know what a role is, and the role would be ADDS, Active Directory Domain Services is what that stands for. And at some point in time, you're going to have to go and promote this domain controller, for those of you that knows on-premises Active Directory, and there's quite a lot of stuff to do here. It's definitely not rocket science, but what it is it's time consuming. Very time consuming. Now, what these cloud providers, like Microsoft, obviously it's not limited to them, what they've done now is they've looked at the market, they've checked what is there that people, our customers or clients, what is there that they don't want to do and don't have time to do. And they went and did it for you, and they sell it back to you as a solution. So that is what platform as a service is. They basically went and looked at the market, now obviously from a IT perspective specifically, and a cloud perspective specifically, so they know we don't have the time to go and make an Active Directory. We don't want to go make an Active Directory because it's very inconvenient and it's very time consuming. So what if they did it for us and they sold it back to us as a solution? Now, Active Directory is just one such example, guys. Other examples will obviously be if you go look at SQL Server. So if you go and upload your SQL databases and stuff like that onto Azure, it's very much the same concept, guys. That is also an example of platform as a service, depending on how you go about it on the Azure platform. There's multiple ways you can go about it, and if you do it the right way, it can potentially also be platform as a service. So now, once you go and choose platform as a service, whatever solution you choose, whether it be Active Directory or whatever else, you basically just get to swoop in at the last minute and reap the benefits. You don't actually have to do any of the hard work. You're still going to be doing some work, don't get me wrong, but the work is going to be minimal compared to what it could have been. I mean, you don't have to go and create an Active Directory now. So if we're talking about Active Directory here, you don't have to go and create a server or build a server. You don't have to go and install a server operating system. You don't have to go and add roles. You don't have to go and promote domain controllers. None of that. You can pretty much just jump in, start creating user accounts, start creating groups. I mean, how awesome is that? Then moving on to the third one on our little list here, folks. Software as a service. That one is the one where you've got the least amount of control. Now, if you've got normal software or applications on your laptop or desktop, that's all it is. And even if you were to go and install this on your company's server and you access it remotely via your own network, that's still all it is. It's just software. I mean, I suppose we could technically call this maybe remote desktop. We could potentially call this remote app, depending on how you went about it. But it's not software as a service because the server still belongs to you. Remember what cloud is. So software as a service is when this software, whatever it might be, is installed somewhere else and it is running somewhere else on somebody else's server. This could be anything. Now, Office 365, guys, is ironically very much a very good example of software as a service. Pretty much everything on it is software as a service. Now, depending on the license you hold, you'll find you have the ability to go and open Word, Excel, PowerPoint, Microsoft Teams inside a web browser. You do not need to have these things installed on your machine. As long as you've got yourself a screen, and as long as you've got yourself an internet connection, which is fairly fast and stable, there you go. That's software as a service, folks. Now, something else I want to mention to you guys, just before we move on over to the next topic here, is third-party vendors. Now, there's obviously many vendors out there that we can go and make use of. I mean, a couple of big names I've thrown here into the course for you guys with this topic today was Microsoft and Amazon. Microsoft's Azure platform, and with Amazon it was that AWS platform. There's lots and lots of other third-party platforms out there as well. Whatever third-party platform you, your company, or your client's company decides to use, make sure you check them out first. I'm not bad-mouthing them here, but make sure from a functionality and a feature perspective that they're able to do what you want them to go and do. Make sure from a cost perspective that it's not unreasonable. And also what's especially important here, guys, is make sure they do backupping properly if it is their responsibility. And also very, very important, make sure the security is the way it's supposed to be. I mean, if you need to, maybe even go and test the security. You never know. Right, folks, let's move you guys on over to the next topic. Benefits of using cloud computing. Now, if I'm being perfectly honest here, these topics which I'm about to list to you guys is something you'll see in a lot of cloud courses. Official cloud courses. These would be official cloud courses from Microsoft. They would be from CompTIA. They would be from AWS. These topics are in all of these courses which I'm about to mention, and it's usually kind of sort of a marketing tactic. And what I'm about to list to you guys is for the most part true. You know, quite often when, if it's a marketing case, you might find a lot of the stuff is not entirely true. With this stuff, I wouldn't say it's 100% true, but it's at least 95% true. So they're going to be bragging through me to you guys about their cloud platforms, and they're going to try and persuade you guys through me to try and move your stuff to the cloud and to start using the cloud. Anyway, so with that mumbo jumbo out of the way, guys, the benefits of cloud computing is things like cloud computing is cost effective. Now, what I mean by that, guys, is if you go look at stuff on premises like your servers, if you've got to go and buy or build a server, how much is that going to cost you? It's going to cost you an arm and a leg. It's definitely not cheap, guys. You're probably going to have to go and buy spare parts for that server, or at the very least, get yourself an SLA agreement with some sort of organization that can come and change and fix stuff for you if something eventually breaks. Now, these servers, on average, they last the average company approximately 3 to 5 years. Now, granted, there are companies that will push this a little bit further. They might push this 5 to 10 years, 10 to 20 years, which is not advisable, but I know of quite a few companies that are doing that. There's obviously lots of risk associated with that, because if something breaks now, you might not find a technician that knows how to fix that, and you might not find spare parts for that. So you're going to really find yourself in a pickle of a situation, which is not something you want to be in. Now, when it comes to buying these servers, you're going to have to do that on average. For the average company, every 3 to 5 years. And you'll find in a lot of companies this can potentially cost you millions. It is very expensive. Then we have not even accounted yet for the spare parts or the SLA agreement you've got to have in place to maintain these servers. We have not accounted for the server room that you've got to put all this stuff in. The server room, somebody's going to have to build a server room. That's not cheap, guys. That server room needs to have proper ventilation, specifically air cooling, air cons. There's going to be multiple ones. They're going to be running day and night on minimum setting the whole freaking time. The air cons themselves cost money, the installation costs money, and the power bill, that's going to cost you money. Now, speaking of the power bill, these servers, guys, you wouldn't believe how power hungry they are. They are insanely power hungry. That's another thing you've got to go and account for. So the list of associated costs just goes on and on and on. Now, if you go and create or move your stuff into the cloud, it's going to cost you a fraction of what it would have costed you. Now, the cloud, in case I haven't mentioned it before yet, you only pay for what you use. If you don't use something, you don't pay for that something. So with that in mind, if I've got myself a bunch of virtual machines, if I'm not using them, maybe it's over the holiday period or something, you turn them off. If you're not using them, you're not going to be paying for them, or at least you're going to be paying a lot less for them. How awesome is that? Now, you'll find that if you go and create a component in the cloud, and it'll normally show you what it's going to cost you per hour, for your company, but in reality, it's a per minute billing system. Now, if I've got myself, let's say, a virtual server, it's a virtual machine, which is a server. The more RAM I add to the server, the more the server is going to cost me per minute. The less RAM it has, the less it's going to cost me per minute. And obviously, the longer it runs, the more it costs me. As simple as that. If I were to go and add more servers to help cope with the load, that's going to cost you more per minute. And if you eventually don't need those extra servers, then obviously you can go and turn them off. That is not something you can go and do on premises, guys. On premises, it's not as quick and as easy to go and upgrade an existing server or to go and add more servers. That's called scaling, which brings us to our next topic here. Cloud computing is scalable. You can very quickly and very easily go and do something called vertical scaling, also known as scaling up. So that is when you go and take an existing server and you go and add more resources to it, like adding more hard drive space, potentially more hard drives. You're going to go and add more RAM to it. That is called scaling up. You're just upgrading or beefing up your existing servers. Then you get horizontal scaling, or as some people call it, scaling out. So instead of upgrading a server, you're going to be adding more servers. Clone servers. Both of these scenarios are seen as scaling. Now, we can definitely go and do this on premises, but on premises, it takes a lot of planning, a lot of testing. You're going to have to go and budget for it. And once you get the green light, it's not as simple as, hey, let's quickly go and do it. No. You're going to at the very, very least have to wait until after hours, because you can't just go and willy-nilly till the server's off and stuff like that. Absolutely not. Usually, you're going to have to wait until a Friday after work, potentially over a long weekend. Now, that's a problem, guys. You might not have spare parts on site as well. So if you want to go and upgrade a server, do you have the spare parts? You might need to go and order them. That could take days, weeks. If you want to go and add more servers, that could take days, weeks, or months in some cases. And you might still need to go and build the servers. You may or may not need to go and still install server operating systems and do all the configurations. So it's not a situation you want to find yourself in. And once you go and upgrade these servers, or you go and add more servers, you are stuck with them on premises. In the cloud, that's not the case. In the cloud, you're not stuck with them. If you don't need them, you can always go and decrease resources or decrease your servers. And if you do need to go and scale up or scale out, you can do that nearly instantaneously in the cloud, guys. Another benefit here, guys, is cloud computing is elastic. So with this, we refer to the rubber band effect. That means you can very quickly and very easily go and scale up and out, something we did mention indirectly. So if I need to quickly go and increase my RAM of a virtual machine that's about to go and crash, I can do that nearly instantaneously. On premises, no, you can't always go and do it that instantaneously. Sometimes you may or may not need to go and turn a virtual machine or a server off. You may or may not need to go and restart it. There's going to be delays. You might have to go and plan for downtime. In the cloud, it is nearly instantaneous. And here's where it really gets interesting. this can be done automatic. In most cases, it is done automatic. I mean, do you really want to go and sit there and keep an eye on your resources every day, the whole day, just in case one of them may or may not be running out of resources? I mean, nobody's got that kind of time. So instead, if your components in the cloud, let's say it's a virtual machine once again, if it's running out of RAM, they can automatically add more RAM for you. And if they see the demand goes down, they can automatically decrease it for you. And before you ask, yes, you will be paying for that. So if they automatically increase it for you, and since you're paying for what you use, yes, there will be additional costs involved. But on the other side of the coin, if they automatically decrease it for you, your costs will automatically go down as well. Now, if you're concerned about this increase in costs, you can go and specify a limit, guys. A cap, if you will. This can be in monetary value, or you can go and specify it in resources. You can tell them, hey, please don't increase more than this amount of RAM, or please don't go and increase this in more than this amount of bandwidth, or more than this amount of, hard drive space, whatever it might be. Another benefit, folks, is cloud computing is always current. That means you've got the latest of the latest and the best of the best always. On premises, yeah, you can achieve that, but good luck doing that. It is a mission of note. Whether we're talking hardware here, guys, whether we're talking software here, guys, in both situations, it's a mission of note. Let's imagine for a moment it is the server operating system on your server. To go and upgrade that to a newer version of server is going to be an immense amount of planning and testing and budgeting, and I can almost guarantee you something will go wrong. Something almost always goes wrong. And there's going to be downtime as well, never mind all of that. And if you go look at the actual hardware side of things, if you need to eventually go and upgrade the hardware of your server, that's also going to require planning and testing and budgeting and all that, and something might still go wrong there. It is a huge inconvenience. Never mind something going wrong and all that, and the planning and the budgeting and all that. In the cloud, it is not your responsibility. It is not your problem. You'll automatically always have the latest of the latest and the best of the best. I mean, I really sound like I'm selling you guys something here, am I not? Now, I promise you, I'm not selling you guys something. This just really is the course. Lastly, guys, there's actually a lot of benefits, but I'm going to mention one more, which is part of the course. Cloud computing is reliable. They give you a 99.9% uptime guarantee, most of these cloud providers. Now, I don't have a calculator open in front of me right now because I'm doing a video, but that equals to about 4 or 8 hours per year, if I'm not mistaken. That might sound like a lot to some of you guys, but for anyone that's been in IT that knows their stuff, they would probably tell you that that is amazing. In reality, in the real server environment, 4 or 8 hours for the whole year is absolutely amazing. Realistically, servers get turned off all the time. They get restarted all the time. Sometimes it's for failures. Sometimes it's because of maintenance. Sometimes it's for other reasons. Maybe it's just 5 minutes here, 10 minutes there, half an hour there, a day there. At the end of the day, over the course of a whole year, if you go and add up all those bits and pieces, it adds up to days, sometimes weeks of downtime. So by saying it'll only be down for what, 4 or 8 hours maximum per year, it probably wouldn't even be down that much per year. That is absolutely amazing, guys. Alright folks, let's move you on to the next topic here. The responsibility matrix. Alright, so there's a bit of a diagram / image for you guys to kind of show you guys what I'm talking about here. So what this refers to, folks, is this is the concept of how much is actually your responsibility. You would remember earlier we spoke about the different kinds of public cloud you get. That was infrastructure as a service, platform as a service, and of course software as a service. If you guys look at this little diagram in front of us, if you look at the one there on the right hand side, the column that says on-prem, or should I say on-premises, the blue blocks there, they represent how much here is still your responsibility. So clearly in the old days, when everything was still on premises, everything was your responsibility. Whether it be building the stuff, whether it be maintaining the stuff, backing it up, securing it, you name it, absolutely everything was your responsibility. Now, if you look there on the left of the on-premises side to those other 3 rows there, clearly we've got a lot less blue blocks there. So clearly we've got a lot less responsibility. Now, as we said earlier, infrastructure as a service is the one that gives you the most control. So you'll see it has the most blue blocks. You still have the most responsibility. Now, if you look at the blocks, they're way at the bottom under infrastructure as a service. There are gray. That will be the data center, the physical data center, the physical network, the physical hosts. So as I've said earlier, you might not be able to see or touch the physical data center. The same goes with the hosts, the network, so the cables, the switches, that kind of stuff. You can't see it, you can't touch it, but it doesn't mean you can't choose it. So yes, I might not be able to touch the servers, but it doesn't mean I can't choose the specs of that server. I can still go and choose exactly what operating system I want to install. And in terms of the hardware, I can choose exactly how much system memory it needs to have. In other words, RAM, how much processing power it needs to have. In other words, your CPU, and how much storage it needs to have. In other words, your hard drive space. That's pretty much the only 3 things there. But yet again, as you guys can see, that's the only 3 things where it's not completely your responsibility. So in the sense of responsibility here, it is the cloud provider's responsibility to go and maintain it, back it up, and secure it. You might have some access to it, digitally speaking, but it's not your responsibility. In terms of platform as a service, obviously, like you would expect, there's less blue blocks. But what you folks will also notice here is a couple of these blue blocks are half blue, half gray. That means half of that is your responsibility, half of it is the cloud provider's responsibility, whoever that might be. Might be Microsoft, it might be Amazon, potato, potato. So it could be your responsibility, could be theirs, it could be a 50-50. And then of course, only way at the top of platform as a service is it completely, totally your responsibility. And then lastly, folks, software as a service, as we've said before, that is the one where you've got the least amount of control. It's pretty much just software or an application that would otherwise be installed on your device, but now it's installed on, the cloud provider's devices, their servers. It's being rendered back to you or the customer or the user as a service of sorts for a monthly fee, and all they need is effectively a screen and a stable, fast internet connection. Right, folks, and then to kind of further elaborate on this, I'm going to first tackle this from the cloud service provider's perspective and then from the user's perspective. So still on the topic of responsibility, who is responsible for what. Starting with the cloud service provider's responsibility. What is their responsibility in all of this? So if I decide now to go and put a bunch of stuff in the cloud, what exactly is their responsibility? And what exactly is my responsibility? So starting with their responsibility, in other words, the cloud service provider, that would be things like the physical security of infrastructure. So whether this be a peewee server room, whether this be an actual data center, whatever, the actual physical security here, guys, is not your responsibility. It is the cloud service provider's responsibility because it's their infrastructure. They are building it, they are maintaining it, they are securing it. On that note, securing computer, storage, and network equipment, the actual computer storage network equipment, it's not your responsibility. You don't own it. You don't manage it. You don't maintain it. You don't secure it. They do. So it's their problem to go and secure this, to make sure it's locked up in a data center, to make sure this data center is locked up, all of that. Also, what's also their responsibility is securing foundational elements of networking. Those would obviously be things such as your distributed denial of service protection. They need to make sure that people don't go and tamper with this kind of stuff. Also, cloud storage backup and recovery. This is a very important one, guys, just as important as security. So yes, it might not be your responsibility to go and back it up and maintain it and recover it, But we better hope they are doing it, which is why it's so important that you go and check out third parties. So if you decide to go with some sort of third party, which is not a well-known institution like Microsoft or Amazon, you better go and make sure of your research. Go and double check it. Make sure these folks do proper backups. Make sure they're able to recover immediately or at least very quickly. Other things that's the cloud service provider's responsibility is security of cloud infrastructure resource isolation amongst the tenants. So if I have something on a server of sorts, and I'm sharing that server with other folks, you would remember I said earlier in this module that is called resource pooling. I'm sharing that server with other people. Whether I have a virtual machine on there, a website, a database, it doesn't matter. By default, the concept of resource pooling is going to apply, which means your resources are on the same server as other random companies and people's resources. So yeah, the cloud service provider here needs to make sure that there's proper isolation and security in those situations if these folks, like us now, do not have a dedicated server. Also, tenant resource identity and access control. So who is going to go and ensure that the people are who they claim to be, and that the people are accessing the right resources, and that they're not accessing too much, maybe not too little? Who's going to ensure that the privilege at the end of the day is being enforced here? That is the cloud service provider's responsibility. Yes, you need to go and create the accounts and the groups. Yes, you need to go and choose who has what responsibility and what privilege they have, but it's not your problem to go and enforce it. You need to tell the cloud service provider what privilege who has, but at the end of the day, you can't go and enforce that. It's the cloud service provider's responsibility to go and actually enforce what you have configured and what you have chosen. Other responsibilities of the cloud service provider would be security, monitoring, and incident response for the infrastructure. Kind of obvious, right? And then lastly, folks, securing and managing the data centers located in multiple geographic regions. Now, a lot of these big cloud service providers, they've got data centers in multiple regions, different countries, they're all over the place. So if you look at an entity like Microsoft, they really have data centers all over the world and every continent, with the exception of Antarctica, obviously. So yeah, we're not going to go and include that one here, but all the other 6 continents, they've got data centers in all of them. Unfortunately, in Africa, the last time I checked, they only have 2 data centers, which are in South Africa. One is in the north side of South Africa, which is in Johannesburg, and the other one is in the south side of Johannesburg, but they list this as South Africa West. I don't know why, because it's actually in the south side of the country, but for some strange reason, Microsoft decided to go and call this, I don't know, South Africa West. I don't know why. So yes, they do have data centers all over the world, both Amazon, both Microsoft, as well as these other cloud service providers, but they need to make sure that all these destinations where all these data centers are equally secure. It doesn't help you go and secure one data center, but then you've got another one where security is really lacking. It doesn't really make any sense now, does it? Anyway, folks, so still on the topic of the responsibility matrix, this time we're going to cover the other side of the coin, the cloud service customer side. That's going to be you for the most part. So coming at this from our perspective, or should I say the customer's perspective, the user identity management, that would be our responsibility. So we, the customer, need to go and create the user accounts. We need to go and create the groups. We need to go and enforce RBAC, role-based access control. So we need to go and choose who has what privilege. When do they have this privilege? So what can who go and do? So it's our job to go and tweak the configurations, but it's going to be the cloud service provider's responsibility to go and enforce these settings and configurations that you've now chosen. Other responsibilities that is ours is the configuration of the geographic location. I mean, at the end of the day, they don't know what you want and where you want it. You need to tell them, you know what, boys? I would like to have a virtual machine, and I would like for this virtual machine to be in America. Or I would like for this virtual machine to be in a data center in Ireland, or in England, or in Scotland. You need to tell them what you want and where you want it. They'll make it happen, but they can't smell what you want and where you want it. You have to tell them. You've got to lead them. And then thirdly, folks, the user and service access controls to the services. That is our responsibility. The data and application security configuration. Yes. So, yes, the cloud service provider will give us security. They'll give us the tools and the means to go and do it. But once again, they don't know what you want and how you want it. So you need to tell them with the tools and the settings and configurations they provided you with, you need to tell them or show them what exactly you want and how you want it. You need to go and say, you know what? Okay, I don't want this, but I do want that. I want this way, and I want that way. So you need to go and choose the settings you want. And at the end of the day, they're not psychic here, folks. The second last one here, folks, protection of operating systems when deployed. So a very good example of this would be a virtual machine once again. So if you have a virtual machine in a cloud, yes, it's an example of infrastructure as a service. Yes, it's on the cloud service providers' machines, their data center. And those data centers or those machines is their responsibility. But once the operating system is installed on this virtual machine, whatever it might be, it is completely, totally, fully your responsibility. So if some sort of antivirus needs to be installed on this virtual machine's operating system, that's going to be you. So if any software needs to be installed on top of this operating system, well, that is you guys. Lastly, folks, the use and configuration of encryption, especially the protection of keys, that is once again your responsibility. Alright folks, let me move you guys on to another topic here, which is centralized and decentralized computing. So in a nutshell, this basically comes down to either having everything in one location, you know, all your processing power, your storage, all of that, all in one convenient location, which is normally the case with big, medium, or large size companies. If you go look at decentralized computing, that is having something all over the place. You know, this could possibly be multiple servers spread out over a geographic location. This could be something as simple as a peer-to-peer connection for all we know. So let me start this process by giving you guys a couple examples. Starting with centralized computing architecture, this, folks, is all data processing and storage is performed in a single location. And the name kind of tells you that. I mean, it says centralized computing. So your servers or whatever servers you're making use of, that is all in one location. Whether you own these servers or not, whether you manage these servers or not, that's irrelevant in this scenario. The fact stands that it's all in one location. Centralized computing, folks, is also when all users and all devices rely on a central server for authority. So a very good example of this will obviously be your identity provider, something like an Active Directory. This could be an on-premises Active Directory. This could be a cloud Active Directory. Potato, as long as it's in one location, it's still a central server of authority. Now, generally speaking, an on-premises Active Directory is probably a better example. I wouldn't say the cloud one is not a good example. You know, only if you go and choose one data center, then yes, it'll probably be an example. Now, in terms of decentralized computing architecture, so this will be the exact opposite of what we just said. Your stuff is spread out all over the place. This would be something like user identity management. So if you have user identity management, but it's being managed from multiple places, let's say you have a hybrid Active Directory environment. So you've got Active Directory on premises. Now on its own, that could potentially have been seen as centralized computing. But if you have Active Directory on premises and at the same time now, you've got Active Directory in the cloud, which they call Entra ID, and you've synchronized these two bad boys with one another. Is that still centralized computing? Not so much. That's more decentralized because it's actually technically speaking in more than one location. Also, decentralized computing, folks, this could be increasing important design trends which impact your modern infrastructure. Yeah. Anyway, so just before we move on to the next topic, I just want to quickly go a little bit deeper into decentralized computing. We already know centralized is to have all your stuff in one location, very convenient, blah, blah, blah. But in terms of decentralized, what would be examples of that, you might ask? Well, guys, this could be something like a good old-fashioned blockchain, if you know what that is. This could be a good old-fashioned peer-to-peer network, which we just refer to as a P2P for short. We just normally call this a peer-to-peer. So that is when you don't have a server online per se. Instead, if you want to go and download something online, as an example, you're not downloading from some public server per se. You're downloading that file from other people in the world, whether this be a game, a program, a video, a movie, whatever it might be. You're not downloading this from one server, which is a company server most likely. No. You are downloading this from other people's machines in most cases. This could be hundreds, if not thousands of people's machines. So if you are downloading some sort of thing online, which is probably going to be illegal for the most part, then yes, that'll be peer-to-peer. Then you get content delivery networks. Now this is actually very popular with medium to large size companies, especially large enterprise companies. This is very popular amongst cloud guys. So when you are a huge enterprise company and when you've got your stuff in a cloud, you obviously don't want to put all your eggs in one basket. It doesn't help me very much to put all my stuff in a cloud all in one data center, and yes, they do give you a 99.9% uptime guarantee, but what happens when that whole data center becomes unavailable for whatever reason? It's not necessarily because this data center crashed or burned down to the ground. No, this could be for other weird reasons. This could be those big fiber lines that you find on the ocean floor that basically connects the various countries together across the globe. Now, when these cables break, not if, but when, because they break all the time, mind you, when all these cables break, you could potentially be cut off from your one and only data center. But if you were hosting all your data in multiple data centers in different locations, then yeah, guys, you're not putting all your eggs in one basket, which is ideally what we want. Now, where this also becomes beneficial, which is not really the topic here, is if you've got customers or staff or whatever in various locations in the world. So if all my staff members or customers are, for example, in the United States, then yes, having a content delivery network in the United States is going to benefit me because that's where most of my staff are going to be pulling the resources from. But if I have a content delivery network or a data center that I'm using, and this data center is in Europe somewhere, but the majority of my customers and blah 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 are in the United States, that's not ideal because you're going to have latency. So ideally you want to have your resources in a location where your staff members or your customers are. So if I've got a bunch of staff members or customers in the United States, you want to have that as part of your content delivery network, or at least a data center in the United States as part of your content delivery network. And if you've got a bunch of customers or users in Europe somewhere, then ideally you want to have a data center in Europe somewhere because that's going to be closer to those customers or users, which means they're going to get a lot less latency. And God forbid if something were to happen to those fiber lines in the ocean floor, then yeah, then at least you're not going to be cut off from the world. Other examples, folks, would be Internet of Things. Good old-fashioned Internet of Things, which we just call IoT. This could potentially be normal distributed databases, or Tor. I'm probably pronouncing that incorrectly, I suppose, depending on the country you're in. You'll probably pronounce this differently. It stands for the Onion Router. If you guys are not familiar with this, there's a web browser out there. It's called Tor, I'm probably pronouncing that incorrectly. And this browser can be used to access the Onion network. Now, if you want to, you can go and use this browser just like any other browser. You can go and, watch YouTube videos. You can go onto Facebook and Twitter and do whatever you would normally do with any other browser. However, this browser is the only browser that is able to open onions. An onion is, well, kind of the deep web. The deep web may or may not consist of the dark web, which is about 99% illegal. Folks, please do not confuse the dark web with the deep web. It is not the same thing. A lot of people think the dark web and the deep web is the same thing. It's not. Absolutely not. The deep web is not necessarily illegal. This could be stuff that's unindexed, by, for example, Google search engines and all kinds of things like that. But it may or may not also include a couple of illegal things. Now, the dark web, on the other hand, that very much is illegal things. So you should absolutely not go on there, and I want to emphasize on that even more in the sense of if you don't know what you're doing. So you should really not go on there if you don't know what you're doing, because if you don't know what you're doing, you're going to get compromised, you're going to get hacked in a matter of mere seconds or minutes. So you do not want to be on there if you are not a pro that knows what he's doing. So yeah, generally we have no reason to be there unless you're up to no good, guys. Now the 4 browsers, what one would go and use to access this onion network. So folks, unlike when you go to a normal website where you would go and type in HTTPS or HTTP followed by www, that uses a DNS concept. The onion network does not use that. It uses what we call onions. It does not use user-friendly names like youtube.com, facebook.com, x.com. It does not use those user-friendly names. That is something we use, in a DNS concept that converts IPs to names and names to IPs and all that. It doesn't use that. The onion network, if you go get yourself an onion for a website, it'll have random numbers and letters and stuff in it. And unless someone gives you that onion, you would never be able to get to that website. So it's kind of like I pass it on to you and you pass it on to the next guy kind of situation. That's pretty much how it works. Anyway, folks, I'm going to move you guys on to the next topic, which is the last topic for this specific section. And then we'll move on, of course, to the next section. So this last topic for this section is cloud architecture features, folks. So the first thing we want to mention here is considerations for cloud infrastructure. So if you're going to go get yourself cloud infrastructure, guys, there's bound to be a couple of costs involved here. Fortunately for us, it's not as much as having stuff on premises. Now, on premises, if you're going to go and buy yourself a server or whatever, there's going to be a lot of cost involved. Cloud-wise, you're for the most part just renting this. You're paying a monthly fee, and as long as you pay your monthly fee, you're going to have access to your resources. So cloud infrastructure, all you need to do is just make sure you pay the bill and make sure you tell your cloud service provider what you want and how you want it. Cost-wise, it's normally a monthly fee. There are options to go and pay this yearly. Now, coming at this from a company perspective, you'll find that these huge cloud service providers like Microsoft, like Amazon, and a couple of other well-known ones, they often offer these huge deals where they'll say, you know what, you'll get an X amount as a discount, 40%, 50%, 60% discount if you sign a contract of us for, let's say, 3 years or 5 years. Now, the benefit of that is you get a massive discount for your company. Drawbacks would be you are locked into that agreement, and it's very difficult to get out of that. So if you find that that specific cloud service provider you've chosen is not ideal for exactly what you wanted to do, then, well, you're kind of stuck with it, boys. And then, folks, cloud architecture, they give you scalability. Now, of course, you know what scalability is now because we explained that earlier in this section in this module. That's having the ability to go and add resources to a server or something. Maybe potentially drop more servers or something, So cloud architecture gives you that ability. It's very quick, very easy, and very affordable. They give you resiliency. It's very resilient. I mean, at the end of the day, you get a 99.9% uptime guarantee. The chances of stuff being down is very unlikely because they've got high availability. They double up on absolutely everything. They've got 2 or more of everything. So the chances of something going down is unlikely. And should something go down, which is very unlikely, they can get it back up and running in almost a matter of seconds. Sometimes immediately, actually. The ease of deployment, especially if you go look at things like software as a service and platform as a service. In most cases, the cloud service provider makes it so freaking easy. You just need to tell them basic things and there you go. Ease of recovery. It's not like in the old days where you had to go and do absolutely everything. You had to go and do the backups. You had to have a very good knowledge and understanding of backups. And when the poop hits the fan, you are going to have to go and restore that completely from scratch with no help whatsoever from anybody. Now the cloud, it's usually their responsibility to go and back up most of the stuff and maintain it. But the little few parts that is your responsibility, it is very, very easy to go and do, guys. Other features would be your SLA and ISA. the power. I mean, at the end of the day, you're not really paying any power here. Not really, because everything is online. So even if you have absolutely no power where you are right now, no electricity whatsoever, a complete blackout, will that affect your business? Not really if your stuff is hosted in the cloud. So if your users or your customers or your clients or your staff members are working remotely from home, as long as they've got power wherever the heck they are, then it doesn't really affect your people now, does it? And then, of course, guys, compute. Compute is a huge category in the cloud. It's not really something specific. This category includes, but is not limited to, things like your virtual machines, of course, which we've spoken about quite a few times. It includes your containers, if you know what a container is. It includes your virtual networks and many, many other things. Alright folks, so we've reached the end of the first main section. Before we move into the second main section, this is the part where I played a good old-fashioned game with you guys. So not in all my videos, but in a lot of my videos I tend to play a bit of a game. This is completely optional, you guys don't need to play this, but for those of you that do want to play this, I normally give a secret word or a secret phrase somewhere in the video. Totally random where in the video it's going to be. And the idea here is, for those of you that want to play along, is to take this word or this phrase I give you, to go to the comment section down below and to make a new completely random sentence using that word or that phrase. Now where it gets fun is when people have no idea what's going on. So if somebody has not watched the whole video yet and they just randomly go through the comment section, they're going to be very confused. They're going to be like, what the heck? Why are the people talking about blah blah blah? Meanwhile, it's because you guys are making new sentences with this random word or phrase I've given you. So it's just for gags. It's just for giggles. It's a bit of an inside joke between us and the people that has not watched the whole video yet. So it's purely just for humor. But you are still very welcome to go and ask any other questions you still want to go and do down below. So if you want to ask any other questions, by all means, ask them down below and I will still get back to you as quickly as I possibly can. So guys, today's hidden word or phrase is apples. Totally random, apples. Let's see who can come up with a phrase using the word apples. So make a new sentence or a phrase using the word apples. But if possible, try and keep it to IT. So let's make it interesting. Use the word apples, make a phrase or a sentence, but keep it to IT. I can already tell you, a lot of people are going to think of Apple, the operating system. So let's see if you can keep it to IT, but not refer to the operating system. So use the word apples, make a sentence or a phrase, keep it to IT, but don't refer to the Apple operating system. Those are the rules. And of course, stick to YouTube's rules as well. So no swearing, don't be mean, all that. We don't want the YouTube popo in our case here. So let's see who can be the most creative here. That's obviously just for the guys that's up for it. The rest of you guys, you can just skip to the next section. So guys, the next section here is embedded systems and zero trust architecture. Right folks, so I think you guys can probably guess what the first main topic in this section will be. That is embedded systems. On its own, the name kind of sounds complicated. So these are specialized computers, guys. Very specialized computers that are going to serve a specific purpose. I mean, this could be something as simple as your coffee maker. I kid you not. Your coffee maker, it may or may not have a processor in it these days, but it's still a specialized computer of sorts. It's an embedded system of sorts. Now granted, a coffee maker might not classify as a computer per se, but some of these embedded system examples that I'm going to give you, they do have processors in them, and they are kind of sort of computers that serve a specialized purpose, if you want to put it like that. So these specialized computers, or not computers, let's just say embedded systems, they could be for many consumer uses. They could be for commercial uses. So if you look at this from a consumer perspective, I mean, this could be your coffee maker, it could be your washing machine, could be your fridge these days. It could be your infotainment system in your car these days. Coming at this from a commercial perspective, I mean, this could be a robot in a factory for all we know. We don't know. So these days, folks, as fellow security professionals, it is very essential for us to actually understand the concepts related to these embedded systems. Now these embedded systems, which are half the time, if not more than half the time, we're going to be IoT, which is just short for Internet of Things. Internet of Things, guys, is everywhere around us. You might not realize it. If you look at something like your car's infotainment system, that's not just an embedded system. It's got a processor in it. It's got a computer of sorts in it. That's an example of IoT. And if you look at just the right example, if you look at something like these fancy smart fridges we've got these days, it's got a screen on it, it's got a built-in computer, it also has a processor, it's also a computer of sorts. Those are examples of IoT. If you look at an ATM where you go and withdraw money or deposit money, that operating system running on it, guess what it is? It's IoT. So these IoT industrial controls, guys, these are zero trust architecture examples. As the adoption now, of course, of these embedded systems and IoT devices continue to increase across industries, they obviously introduce new and unique security challenges. And it's just going to keep getting worse, guys. So understanding these technologies is absolutely crucial for you guys for implementing appropriate security measures. It's also crucial for you to ensure resilience and maintaining the integrity or the critical infrastructures in your company or that of your client. So as fellow security professionals, guys, we must also be well versed in the zero trust concepts, emphasizing the newer trust always verify principle. Now obviously, guys, having knowledge of these concepts, that will empower us as security professionals to mitigate these risks in this ever-increasing complex world that we find ourselves in, where everything is getting interconnected nowadays. So on the topic of embedded systems, guys, I'm going to give you guys a couple of more, well, let's just say better examples. So these embedded systems, guys, they are used in various specialized applications. And this includes, but it's not limited to, consumer electronics, industrial automation, automotive systems, medical devices, and much more. Now, a couple examples would be things like your home appliances. You want an example? Well, guys, that is things like your refrigerator. This could be a washing machine. Well, you have to look at the right one, but it could be a washing machine. Even the ones that don't have a fancy LCD screen, it's still an embedded system. It may or may not have a processor, but it is an embedded system. Unless if you look at those old legacy washing machines from 20 years ago, that doesn't really count. So it could be a refrigerator, could be a washing machine, could of course be that coffee maker I spoke of earlier. All of these contain embedded systems that control their functions and their operations. These embedded systems could be something more technical, like smartphones and tablets. So that contains a variety of embedded systems actually. This includes things like processors, potentially sensors, and communication modules. This could be maybe more industrial related. This could be your automotive systems, like your modern cars. They contain embedded systems including the engine control units, entertainment systems, and safety systems like airbags, and of course your anti-lock brakes, which we just call ABS in most cases. Embedded systems, guys, could be industrial automation maybe. So this would be embedded systems that exist in control systems and machinery, such as those robots you would sometimes find in factories. It could be those assembly lines or those sensors you might find in those industrial automation places. This could be medical devices, guys. This could be things like your pacemakers. Believe it or not, a lot of pacemakers, guys, they use IoT. So these doctors that go and install them, they actually have the ability to go and remotely configure them. So yes, they can be hacked, in case you're wondering. They can be hacked and you can give someone a heart attack remotely. That's a very scary thought. So yes, it includes things like pacemakers, insulin pumps, blood glucose monitors. All of these contain embedded systems and their functions can be controlled remotely by healthcare providers. And then I'm going to give you guys one more. Aerospace and defense. I mean, of course, it makes only sense, doesn't it? So this will, of course, include things like your aircrafts, your satellites, military equipment. All of these use embedded systems, but I think that's probably where it all started, isn't it? A lot of the technology we have these days, it all started normally with military. If it wasn't for this conflicts and wars and stuff we have these days, we probably would never have all the technology we have these days. So yeah, at least something good came out of it. And then one last little teeny weeny thing I want to mention before we move on to the next thing here. Real-time operating systems, guys. We just call these RTOS for short. You're probably wondering, what is that? Well, guys, this is a type of operating system which is designed for use in applications that require real-time processing and real-time response. They are purpose-specific operating systems which are designed for high levels of stability and processing speed. So whenever you find yourself with something that needs a very high level of stability and processing, it's a very purpose-specific operating system. This is the one you're going to go and make use of, guys. Alright folks, moving you guys along. So since we are kind of sort of talking about Internet of Things here, that brings me to the topic of, well, you guessed it, Internet of Things. I think at this point in time you guys have got a fairly good idea of what the heck this actually is and what it entails. Now, just in case you still don't quite understand, guys, Internet of Things, this is a network of physical devices, vehicles, appliances, and other objects which are embedded with sensors, software, and connectivity, which enable them to collect and exchange data. So once again, I'm going to refer to things like those ATMs I spoke of earlier. If you go to an ATM, that is an embedded system, is it not? It's got a processor, not all of them do, but that one does. It's got its own operating system, and it is interconnected with other ATMs and of course the bank. So if you go and withdraw money, it is able to tell the bank how much you're withdrawing, and it's able to go and check how much funds you've got available. Other good examples of IoT, which have got processors and operating systems and stuff like that, that will be the infotainment systems in the latest modern cars these days. They've got these huge screens in the middle of your car. They've got color screens, they've got a whole operating system, and you can go and connect to the internet, you've got satellite, you've got absolutely everything. And if you've got a lot of money to throw around, some of the items in your home, your smart home, might also be IoT. So if you go and, let's say, close the blinds or open the blinds, or you can go and turn the lights off or dim the lights with the clap of a hand or with a remote or your phone, that's an example of IoT. Now those last couple examples I gave you guys, they may or may not have processors involved, but still, examples of IoT. Now lastly guys, still on the topic of IoT, the significantly decreased cost of IoT sensors and devices over the past few years has obviously made them, well, very affordable and very accessible to businesses and consumers. So they have been around for quite some time, but they were not always everywhere because in the beginning, since people were not really using them, they were very expensive to go and implement. But nowadays, of course, since they're everywhere, there's a high demand for this stuff. Supply and demand. Classic case of supply and demand makes the price go down. So it's very cheap and very easy to go and implement these days. And then the very last thing I'll mention here, guys. Advances in connectivity technology such as 5G and obviously low power wireless networks. This has made connecting and managing very large numbers of IoT devices much, much easier and much quicker than obviously ever in the past. Right folks, let's move you on to the last topic in this section and also the last topic in this module. Right, so that would be the zero trust methodology. Now I can guarantee you this will be asked in the exam. So I'm going to discuss two things here with you guys. I'm going to discuss the zero trust guiding principles that they will ask you in the exam. And I'm also going to discuss the 6 foundational pillars. Now that I have not seen in the exam, I'll still discuss it because you never know. CompTIA does reserve the right to change the exam whenever they want, however they want. So it's still a good idea to know this stuff, to understand this stuff, not just from the exam perspective, but also because you're going to have to know this stuff when you go into the field. But for the time being, at this exact moment, if you're going to go and write the exam, you only need to know the zero trust guiding principles. So let's start with that. So starting with the zero trust guiding principles, guys, that consists of 3 things. The first of which is verify explicitly. The second one is the least privileged access principle. So that's a golden rule in IT, of course. And then the last one is assume breach. So now that we've got all 3 there, what do they actually consist of? Now, verify explicitly, folks, means you are a very paranoid IT person. I mean, that's a good thing. It's never a bad thing. So you are going to go and force everybody to go and verify around every corner. So if they want to log into a new app, if they want to open a new browser tab, a new browser, go to a new machine, a new device, absolutely everywhere, on absolutely everything, every person will have to go and verify that they are who they claim to be. It's not a matter of, hey, I've got a browser session open and I've already logged onto this platform, so if I go to the next platform, it's not going to ask me to log in anymore because of single sign-on. No. That is seen as a security risk. It might be very convenient and it might save your users a lot of time in the sense of logging in, which means they've got more time to spend on actually doing work instead of just logging in. But the downside to that is it's not very secure. So if somebody, kind of left a session open where they were really logged on and then they step out for lunch, yeah, you can do the math. What's going to happen here? Another guiding principle, guys, which is a more obvious one. I think a lot of you guys know this one. Any IT person in IT that's worth their salt would know this rule. It's a golden rule in IT. It is the least privilege concept. You never give someone, or something for that matter, more privilege than what they need to achieve a task or a goal. This includes even yourself. Yes, you heard me, yourself. And if you're wondering why yourself, well guys, imagine for a moment the account that you use is an admin account, because it's probably going to be an admin account. Imagine that account gets compromised. It gets hacked. That's a problem, right, isn't it? So if you are the main IT admin in a company and you've got a very high privileged account, and it happens to by some chance get compromised, can you imagine the damage that perpetrator can go and do? We call these people threat actors. What they can do and what they can see can be disastrous. So by giving yourself just enough privilege to do what you need to go and do, you are limiting what that perpetrator can go and do, and you are limiting what they can go and see. So you're not going to stop the damage, obviously not, but you can at least limit it. It's obviously also quite useful in the event of someone going rogue. So if you've got employees that are, maybe going to your position, or they're going rogue, or whatever the case might be, it's very useful in those situations as well. Unfortunately, these folks may possibly still be able to see some stuff and do some stuff, but you can limit what they can see and do. So yeah, if you are the main administrator, guys, yes, I'm not saying you can't go and make yourself a main admin account, but only use that account if you absolutely need to. So if your normal day-to-day tasks, create an admin account which is very limited and has just enough privilege for you to do what you need to do on a daily basis. Then the third guiding principle, folks, is assume breach. Now if you go and assume your company or your client's company has already been breached, even if it has not been breached, let's just pretend for a moment your company or your client's company has been breached. Let's pretend for a moment there's some random hacker in this IT environment. Now if you pretend or imagine there's an IT hacker in your environment, your whole perception, the way that you are going to go and protect your network is going to be completely different. For example, something you might go and do now that you might not have done previously is to go and segment your network, to go and subdivide it into lots of small little divisions. So previously, if you had just one big network and I got past your firewalls or whatever security you had, I would have access to your whole network. But if your network is now segmented, it's divided into lots of small little sections. If I'm a hacker in your network and I manage to get in, I might very well only have access to one small little section of your network now. Not the whole network, because it's been subdivided into lots of small little networks. So you need to go and re-verify that you are who you claim to be in each and every one of these little segments. So if you pretend or imagine for a moment that you are actually already hacked, you're going to see the way you go about enforcing security is going to be completely different. So that's a very good thing to go and do in IT, guys. So folks, those three guiding principles I've just mentioned, discussed, make sure you know them, make sure you understand them, because they will probably ask you that in the exam. Then the last thing I'm going to discuss with you guys today is the 6 foundational pillars. If you're wondering what that is, it consists of things like identities. What do I mean by that, you ask? Well, guys, identities, they may be users, services, or identities. Now, if I say users, you probably thought of that, because normally when we say identities, we think of people's user accounts. But identities, guys, could also be devices. Yes, devices consist of identities. A device is an identity. A service is an identity. Each and every one of these things has its own identity. So a user would have a user account. A device will be listed as a device, but that's still seen as an identity. Another pillar would be devices, mind you. So devices, they create a large attack surface as data flows. So you need to make sure that you go and secure these devices. Something to keep in mind. A third one would be the actual applications you and these users use. So applications are the way the data is consumed. Of course it is. The fourth pillar, folks, is the actual data itself, mind you. So data should be classified, guys. It needs to be labeled. It needs to be encrypted. If it's not classified, it's going to be organized wrong. If it's organized wrong, it's not going to be secured properly. Maybe there was supposed to be encryption on it, but because it was not classified correctly, encryption is not going to be applied, and before you know it, somebody's going to see something not supposed to. So it needs to be classified correctly, it needs to be labeled correctly, and my goodness, definitely needs to be encrypted where it needs to be encrypted. The fifth pillar, guys, almost done, is infrastructure. So infrastructure, whether it be on premises or cloud-based, this represents a threat vector. It means if I'm the perpetrator here, the threat actor, I can go and try and attack this, this infrastructure of yours, whether it be online or whether it be on premises. And then the very last one for today, guys, but don't disappear once I'm done, is of course the networks. The networks, like I said earlier, they need to be segmented. Assume you've been breached. Alright folks, I really hope you guys have learned something today. If you have, do me a favor and let me know down below in the comment section what you've learned. Also, do me a favor and give this video a like. I do put a lot of effort into these videos, and they are for free after all, so think of the like as payment, I suppose. If you'd like to know when Module 6 goes live or any of my other contents, maybe consider subscribing, guys. And then, like usual, a bit of a shout out and a thank you to all the supporters of this channel. If you would like to support this channel in some sort of way, guys, you can find out information in the video description down below, along with my Discord server link and my Patreon link if you guys want to go and check out my Patreon. So guys, thank you to those of you just doing donations, buying me coffee and milkshake. You can find that link down below. Just giving me a super thanks. And of course, the PayPal donors, guys. Thank you very much for making those donations in the background. And then all the Patreons. Now, unfortunately, all the Patreons are not listed here. You've got to be a paid Patreon. And if you are one, I would normally ask you, do you want to have your name displayed? And unfortunately, 4 out of 5 people, if not more, opt to stay anonymous. But if you say yes, I will normally ask you what name you want to have displayed here. So you do have the option to go and choose what name you want to have displayed here if you are a paid Patreon. Now, on that note, guys, on my Patreon, you can normally find additional material over and above what you would find on YouTube. So yes, on YouTube, you would normally find free practice questions where I will go through each question and each possible answer and discuss them with you guys. But these are theory-based. If you want more practical-based questions, that is normally found on my Patreon. So feel free to go and check that out. Lastly, folks, I did mention it earlier, the channel does have a Discord server, so if you did not know, the link for that is in the video description down below. It's literally the very last link in the video description at the very bottom. Alright folks, I will see you all in Module 7 of the Security Plus.